Alright, so for our first problem, it's asking to describe a single transformation that could map figure A onto figure A prime here. If you can see in our first example, they already did a translation of 8 units up. So they already did a translation. So that means we have left is our rotation and reflection. So one way you can go from A to A prime is, so if this is our line of reflection, we can see that this point is 2 away, just like this point is. Same thing for this point is 4 away, as is this one. And then this point is 6 away from the line of reflection, just like this one, etc. So we could do a reflection across the x-axis. What is a transformation that would not map it onto? So we know we can do translation, we know we can do a reflection, which means that we cannot do a rotation. And one way to know that for sure is, so let's just take any random point. So I'm just going to use this point right here at the top of each of our figures. So this point right here is at -1, -4. If we rotated the figure one time this way, that would be a 90 degrees clockwise rotation. And remember that when we go 90 degrees clockwise, that is the same as y -x, which means that we have to switch the positions of the two. So our -1's over here, our 4 is over here. And then we have to make what was our x value, so this -1 is opposite. So this would become 4, 1. So we go over 4, up 1, which means clearly it is not a rotation since it is here and not here. For problem 2, Sarah is using a digital art program to draw figure Y and then its image, which is this Y prime here. So what are the 2 ways that Sarah could have made those two? So again, we're looking for 2 ways that she could have done this. So let's try a translation. So we'll pick any random point. So I'm going to use the one right here. So we can see, or do you see how it's facing this way? And then suddenly now it's facing this way. That means that its orientation changed. So it was facing this way, now it's facing this way, which means it cannot be a translation, so that must be a reflection. And we can see it's a reflection along the y-axis. And it also must be a rotation. And since we are going from this quadrant over to this quadrant, that means we went 90 degrees counterclockwise. So CC for counterclockwise. So now we are on page 38. So we see that Mani is drawing an octagon Q and its image Q prime in the coordinate plane. And she wants to be able to identify at least 2 single transformations that could map octagon Q to octagon Q prime. So we need to draw and label a possible octagon Q and Q prime that she could use. So one example that you could use, but I'm sure that there are others. So let's say that we put our Q here, here. Sorry, my drawing's not very good. Here, here. There's our octagon. this will be our Q. Now we need to do Q prime, so I'll make that blue. So let's say we want to put that here. So we go. That's our Q prime. When we do that, we can see that we could go from our red to our blue, so our Q to our Q prime, by translating the figure. We would have to count to make sure, so 1, 2, 3, 4, 5, 6, so we could translate 6 to the right. Or our other option would be that we see our points are equal distance from our y-axis here. So we could say that it is a reflection. So 1 away here, 1 away there. 1 here, 1 there, 2 away, 2 away, etc. So it could be a translation of 6 or a reflection over the y-axis. And this is just one example. You could also use others, but this is just one example you could do. Then for number 4, we see that Ravi draws this triangle ABCD in the coordinate plane and uses a single transformation to form this new one right here. So what transformation could he have used and label it to show? So we can see that this could be either a reflection, so see they're each 2 away from the sign of reflection, or we could say it's a translation. It can't be a rotation because our rectangle was like this, and if it was rotated, it'd go like this. So it has to be either a translation or a reflection. So we'll do for our first one a translation. So translate, which means that our A is up here, so that would mean our A prime would be right here. Our B prime would be right here. Our C prime right here, and our D prime right here. And we translated it 1, 2, 3, 4, 5, 6 down. So that's one way we could do it. Another way, like we mentioned, it cannot be a rotation, so it must be a reflection. So we could say that it is a reflection along the x-axis. And then we must label it. So our D was 2 away here, which means our D prime would be right here. Our A is 4 away from our line of reflection, so our A prime must be right here. Our C is 2 away, so C prime is here, and B prime therefore must be here. So you can see that our vertices are different. So if our vertices are labeled, we would be able to tell which of the transformations was used. But since it was not, we could do either a translation and then label them that way, or a reflection and label them this way. So Ravi says that there's a third single transformation that maps it onto. So we already did translation, we already did reflection, which means all that's left is rotation. And we already talked about how you can't rotate, because if you rotated the rectangle this way and you rotated it, it would go this way for 90 degrees. So therefore, Ravi is incorrect because you cannot rotate. Now, if they did 180 degrees, you could, because again, if you went 180 and you had a rectangle, you would rotate, so it would stay a rectangle. But because they're going one quadrant down, that would be a 90-degree rotation. So no, you cannot rotate 90 degrees clockwise to get from this figure to this figure here.